Well, hello. Welcome back. Here we are.
Talking about blood typing, right?
Yep, we're going to talk about blood typing, which is one of the best examples of a multiple allele trait. Miss Patton here is doing a phenomenal job. We're just coming in, saying hi. We know you miss us, right? Yeah.
Yep. So, good luck with this.
All along.
Once again, if you have any questions, be sure to let us know. Ooh, this is starting out rough, but here we go. All right, so blood typing. I'm sure you guys have heard about like A blood type, B blood type, AB, and even O. And that is another example of multiple.
Poor Spanky.
Spanky just tripped and fell. He's fine. He's fine. Oh. So, human blood types, we have multiple alleles, A, B, and O, and then also codominance, which is what we see with the A and the B alleles. So this is going to kind of change the game a little bit with Punnett squares, because we're still going to use capital and lowercase letters, but because we have multiple alleles, we're going to put a little kind of like exponent letter next to it in order to say which dominant allele it is. So we're going to use a capital I with a uppercase A next to it in order to show the A allele. We're going to use a capital I with an uppercase B next to it to show the B allele. And a lowercase I is going to show no antigens or markings on it, which is what O blood is. So you can have A blood, which means that you have the A antigens or the A name tags on them. You have B blood, which is for the B antigens or B blood. And then the O is absolutely no antigens on there. So, interesting point. Capital IA and capital IB. If you happen to get both of these, they are codominant, which means that your red blood cells are going to have a bit of both. You're going to have a capital A, capital B. You have both name tags on your blood types. So, possible genotypes and phenotypes. And this is probably the best slide to write down, and make sure you commit this to memory. With A blood, you can be homozygous dominant, meaning that you have capital IA, or you are heterozygous, capital IA, lowercase I. So remember that lowercase I is recessive, and that means that there is no name tag produced. B blood type, we have homozygous dominant, capital IB, or capital IB, lowercase I. And then AB blood means that we have one of the capital IA and one of the capital IB. So we are heterozygous because we have two different alleles here, but both of them are dominant, both of them are present, which is what we end up seeing down here in the bottom. Now for O blood, this is where we're going to have the homozygous recessive. Nothing is produced here. And once again, if we have a lowercase I, because it is recessive, whatever the dominant allele that is with it is what is going to be seen in the phenotype. So let's go through and let's start practicing. Heterozygous A. That's going to be the capital IA, lowercase I. So we've got capital IA, lowercase I. The father is heterozygous for B blood, so capital IB, lowercase I. And once again, we got all of this from that previous slide where I went through and I showed you all of the genotypes and the possible phenotypes that are associated with it. We spread these across, and one of the biggest mistakes that I see is that kids will want to put a capital I and then the capital A over on the other one. You got to keep the capital I with the capital A next to each other. They are one unit, they are one allele. So capital IA with the lowercase I. We're spreading these across, capital IB with the lowercase I. When we combine them together, now we get a different combination of genotypes and phenotypes. In the top right, we have capital IA, capital IB. That's going to be AB blood. We have two different genotypes here, which means two different phenotypes as well. This blood type right here is going to be B blood, and this blood over here is going to be A blood. Now in the last one, homozygous recessive, we have lowercase I, that is O blood because no name tags are made. So going through this one more time, we have the heterozygous AB, because it's codominant, we end up seeing both alleles expressed. We have B blood, which is also heterozygous, A blood, which is heterozygous. The only homozygous genotype and phenotype we're going to see is for O blood. So what are their blood types? We're going to go through, and I have made these up just to make our examples a little bit more fun and interesting for you. In order to do this, we have to look at a test. And the test is going to look for those name tags or antigens that we talked about earlier. So if it clumps, that means we have that little name tag on there. So for the top one here, we have that name tag that has the A antigen on it, meaning that they're either A blood or AB blood. Down here, we do not have an A marker, so that means that we do not have any A name tags on there. So that could be O blood, that could be B blood, but it cannot be A blood or AB blood. So, looking at Brooke, she has clumping, and it's really obvious here for the A, but then if you look really closely at the B, it also looks a little chunky. A lot smaller, but it is still kind of chunky, which means that Brooke has the A antigen, she has the A name tag, and she also has the B name tag. So her genotype is going to be capital IA, capital IB. Axel, when we looked at his blood, he has the A antigen because it's also clumpy, but that B is really, really smooth. I don't see any clumping at all. So he only has the A antigen on it. So that means that he has A blood. He only has the A name tag. He has A blood. So his genotype is either going to be homozygous dominant A or heterozygous A, which we're going to look into later. Derek has no clumping whatsoever. So that means he has O blood. Christian, looking at his, he has no clumping in the A, but he does have clumping for the B, which means that he has the B name tag. He has B blood. So he is either going to be homozygous dominant B or heterozygous B. We do not know his genotype yet. All we know is that his phenotype is B blood. So Derek is O blood, Axel is A, Christian is B, Brooke is AB. If you want clarity over how we got those earlier, go back and listen to those slides again, and that will help hopefully explain it. So now let's go into the genotypes with the Punnett squares. Brooke has AB blood. There's only one genotype for B blood or AB blood, and that is this, capital IA, capital IB. So we're going to go ahead and put mom's alleles on the top. And Derek has O blood, which means he's going to be lowercase I, lowercase I. So we go ahead and put his on the side. When we combine these, now we have to read these genotypes. It looks like two of the boxes, capital IA, lowercase I, that's going to be A blood. The other two boxes, capital IB, lowercase I, that is B blood. So 50% of the... Okay, so that last Punnett square we did, we assumed that Christian was homozygous dominant. Now let's look at Christian's family. And once again, I literally just pulled these images off of Google. Alec Baldwin is not Christian's father, okay? So we've got two parents here, and both of them are going to have these blood types. Both of them are AB blood, which if we do that Punnett square, two parents that have A blood or AB blood, 25% of the kids are going to have homozygous dominant A blood, 50% of the kids are going to be AB blood, and 25% of them are going to be homozygous dominant B blood, which means that Christian, if both of his parents have AB blood, is going to be homozygous dominant for B blood. So this takes us back to the who's the father. I'm going to link to this YouTube video, and it is now your opportunity to watch it, and we'll see who was correct.